TAFs are different from METARs in that they describe the forecast conditions at an aerodrome and usually cover a period of between 9 and 30 hours. 9-hour TAFs, or short TAFs, are usually issued every 3 hours, and 12 to 30-hour TAFs, or long TAFs, every 6 hours. The TAF is issued separately from the METAR, but many of the codes and groups in the METAR are also used in the TAF. We shall only consider the main differences in this lesson. Shown here are examples of TAFs for various aerodromes. The first obvious difference is that the reported identifier is now TAF, not METAR. The ICAO location indicator of the airfield issuing the report is the same as that for the METAR. Again, we use Oxford Airport. Remember that the METAR is an indication of the weather at a specific time. However, the TAF aims to give a forecast over a period of time, so the TAF will have a different time group to the METAR. The first of these time groups is the time of issue. The date first, and then the time in hours and minutes in Zulu. So our example TAF was issued on the 13th at 0600 Zulu. In a TAF, the validity time comes next. This is an 8-digit group split into 2 parts. The first 4 digits are the start time of the validity period, and the second 4 digits are the end time of the validity period. So here we have a validity period starting from the 13th at 0700 Zulu and ending on the 13th at 1600 Zulu. So here is a 9-hour TAF. The decoding of the wind is the same as for the METAR, and the example shown here is a mean wind direction of 310 degrees true at 15 knots. Visibility in the TAF follows the same coding rules as the METAR, except that only the prevailing visibility value is shown. In our example, the prevailing visibility is 8,000 meters. The weather coding for the TAF is the same as the METAR, and the table shown here is to refresh your memory. However, cloud coding is slightly different than the METAR. If there is no cumulonimbus, towering cumulus, or if no clouds below 5,000 feet or below the minimum sector altitude is forecast, and CAV-OK or sky clear does not apply, then the code NSC is used. This stands for no significant cloud. Another difference is that only cumulonimbus clouds are ever reported in TAFs, whereas in the METAR, towering cumulus and cumulonimbus clouds are reported. The main TAF information ends at the cloud group. You may recall, though, that the METAR had a lot of extra information after the cloud groups, as shown here. TAFs, however, do not have any temperature and dew point, QNH, recent weather, wind shear or runway state information. Only significant changes of weather follow the cloud group. We will now look at how the significant weather changes are coded within the TAF period. The first change indicator is FM, meaning from. This is followed by a 6-digit time group. The first 2 digits are the date, and the remaining 4 digits are the time in hours and minutes. This means that from the 13th at 12:20 Zulu certain weather changes will occur. This weather change forecast supersedes the corresponding forecast prior to this period. In this example, from the 13th at 12:20 Zulu till the end of the TAF period, the wind will change to be 270 degrees true at 17 knots with a minimum visibility of 4,000 meters and some broken cloud at 1,000 feet. This is just one type of weather change indicator that can be used. If the change cannot be accurately forecast to the hour and minute, then another code is used. The change group becoming, followed by an 8-figure time group, indicates the expected start period of a permanent change in the forecast conditions. These may be regular or irregular, starting at an unspecified time within the period given. By the end of the time period given, the change should have occurred, and the conditions suggested would now prevail. Let's look at an example. The codes you see on the screen indicate that at some time on the 13th, between the 0900 Zulu and on the 13th at 1100 Zulu, the visibility will permanently become 5,000 meters in light rain. Notice that the wind information has not changed. It will still be 310 degrees true at 15 knots. The other change indicator is tempo, meaning temporarily. This is different from the becoming change indicator in that this change may occur at any time within a specified time period, and it will therefore not be a permanent change. These temporary fluctuations are expected to last less than an hour each time, but in aggregate, no more than half the time period given. Let's look through the example on screen. Between the 13th at 1200 Zulu and the 13th at 1400 Zulu, the visibility will fall to 4,000 meters, with the weather being thunderstorms and moderate rain. There will be 5 to 7 octaves of cumulonimbus cloud at 1,000 feet. However, after 1400, the weather will return to the base conditions specified here. A probability indication can be used to assess the likelihood of occurrence and is shown by the code prob. This is expressed as a percentage of either 30% if the probability is considered low, or 40% if there is a high probability of the weather being as forecast. Probability can be followed by a time group as shown here, or by an indicator such as becoming or temporarily. One last thing must be covered before we finish the lesson. When a TAF requires an amendment, the amended forecast may be indicated by inserting an AMD after the TAF identifier, as shown here. Hopefully from this lesson, you will now be able to accurately decode the TAF message. Remember, it is a forecast of the expected conditions, and therefore essential to your MET briefing prior to your flight. If you use TAFs correctly, you'll be in a better position to make accurate and informed decisions about your flight and the expected conditions at the aerodromes you visit.